Hello and welcome to Math 131. This video will cover the second half of week 4's lesson, which is going to be about your own data. We're going to go through the subtopics, subsections of your own data, a little bit in an empty Google Colab notebook, and then a little bit back to this lesson, and then a little bit back to the Colab notebook. To help us get started with the topics in this lesson, I'm going to install a program named Tree onto the computer that is running this Google Colab notebook. Now that's a server that Google owns. I don't own the server that Colab is running on. So we're going to have to deal with that in a number of different ways for this lesson. We're going to use throughout this lesson this exclamation point, sometimes read as bang, to call to the underlying computer that this Colab notebook is running on, to run the program apt-get, and to please really quietly install the program named Tree. Tree is going to help us visualize some folders on this underlying system that the Colab notebook is running on. But for now, let's just do what I think you all are more used to when you start visualizing files on a computer. So over here on the left of all Colab notebooks is a little files icon. And you can see that we are somewhere in the file system of the computer that this Colab notebook is running on. So from where we're standing, there is a folder named sample data, and sample data has some files within it. That I think we're all used to. But actually this dot, oh look, that's a nice tooltip to say, this dot is actually referencing the parent directory of the directory that we are in, which itself contains a folder named sample data. So that's what we're going to talk about first, is directories. So there is another program on the underlying computer running this Colab notebook, and we can call to the program named ls, and it will list all the files or folders, sometimes called directories, within the current working directory. So one dot here says we are currently in this directory. This directory has one directory in it named sample data. This dot is actually referring to the parent of the directory we're currently in. So here are all the folders or directories and files contained within the parent directory. So I just happen to know that we are currently in the directory content. You could see that by calling this one. So we're currently in the directory content. The directory content has a directory within it named sample data. But the parent directory of content actually has a lot more directories and files in it, content just being one of them. So effectively, all computers are structured like this. There are directories of directories of directories and files within some of those directories, maybe all of them, maybe, only some of them. So the directories that we're going to need to be able to read consistently to deal with programming in Python are the current working directory. That's wherever we are currently located. Dot. That dot is referring to the directory named content on the computer that this Google Colab notebook is running on. The parent directory of content includes content as a subdirectory and a number of other things. So here we've got a current directory, a parent directory, and here's how to list the current directory that we're in. There's other ways to visualize directory structure, and that's what this program tree that we've installed is going to do for us. So if we call tree dot, you can see it lists kind of like it does here when you drop down this. It lists a directory within our current working directory, sample data, and indented from that directory, there is a number of files within it. They don't show up in the same order, but that really doesn't matter too much. So tree is a common way in the world of programming to list directory structure. So if we wanted to reference, say, this data set as a CSV file, we'll get to see what CSV files are in a second, but if we wanted to list this data set, we would actually have to do that as relative to our current working directory, go find the directory sample data. Within sample data, that's what these slashes mean, there is then California housing test.csv, a file named California underscore housing underscore test.csv. And this right here is called a file path. Different directories are split up by single forward exclamation point, single forward slashes. Different directories are separated by single forward slashes, and sometimes they separate out a file name as well. So here is the file path for the current highlighted file. Because this file path is relative to our current working directory, we would call this a relative file path. And anytime we want to read in our own data set into the world of Python, what we need to formulate are file paths. For the most part, we're going to reference relative file paths. So this is going to be a file path that we'll be able to do something with later on. But for now, let's go look into what CSV files are. So for this, I'll come back to our lesson, and I'll come down here to delimited files. And here is a table representing a delimited file. For delimited files, the commonalities are the 0th row, if you will, is always the column names of the variables in your delimited file. And from the first row down, from trousers down, are the actual data you have within each of those columns. So here we have like type of clothing, we have size of the clothing item, and color. Each row in a data frame, in a data set like this, is basically the noun of the data frame. So in this case, we have different types of clothing. Sometimes the nouns of a data set like this are called observations. So when we have the observations spread out in rows and the variables on those observations spread out in columns, we basically have rectangular or tabular data. Tabular data is the standard format for delimited files like comma-separated values. And that is indeed what this representation of that data set above is doing. We have all of the values of the data set separated by commas. So the column names are separated by commas, and all of the values of each row are also separated by commas. This is a fairly simple example of a comma-separated value file. You could imagine if you had a data set filled with sentences and the sentences contained commas in them, your computer might get confused about whether or not a comma was a comma from a sentence, like this one, or a comma separating values within the data set itself. There's a number of different issues going on with that detail. Some people try to use different values than commas to separate, different delimiters than commas to separate out the values of a data set. For the most part, the conclusion is just use tried and trusted packages like pandas to read CSV files in for us. Okay, let's do CSV files take 2. Look, here's a CSV file. And if we try to open it, we actually only see the CSV file written out as a tabular data set, where the first 0th row is in bold to help us visualize that those are the column names, and everything after that is effectively just a cell or value within each column. And it further helps us visualize the difference between values with these vertical bars. But in reality, what's going on is this is just a text file where each of these numbers are separated by commas. And we could call to another program on the underlying computer that this collab notebook is running to say print just the first 5 rows of this CSV file. And you can see, for reasons that you can read in our lesson webpage itself, there are quoted values separated by commas. Quoted values separated by commas. And those are giving us the column names. And then the values within the data set itself are separated by commas. And this is what a CSV file is. So you could then, if you import pandas, create a new data frame by calling the pandas function read CSV and then putting in quotes a file path. And there you have it. We just read in a CSV file to pandas as a data frame. And everything from here follows exactly like we have done throughout this entire course so far. There is one caveat here. This CSV file already existed on the computer that Google allows you some access to. So let's try CSV files take 3. Let's say you have your own CSV file that's on your personal machine, but does not live on this computer that the Google Colab Notebook is running on. I'm going to simulate such an environment by going to find a data set on penguins that I know exists. I'm going to save that data set as a CSV file from the internet onto my personal computer. I don't want to append txt, it's just a CSV file. I'm going to go find that data set and upload it to the computer that this Colab notebook is running on. It's named Penguins. So now this Penguins data set lives within the current working directory that I'm in on this computer that is running the Colab notebook. It is not within the sample data set. So if I wanted to read in this Penguin CSV file, I would effectively replace this part of the file path. I don't have to reference sample data, since you can see penguins.csv is not within the directory sample data. It's in the same directory as sample data. Whoops. And then I can run this and run this. And there is my penguins data set. So anytime you want to read in a data set to Python, you effectively need to go find the file path relative to the directory with which you are currently in according to Python. We happen to know that we are in the same directory as sample data, and sample data has the Penguin CSV right next to it.